Hello everyone, my name is Arshita Fatima. I'll be walking through the task 2 of the GRID program by the Sparks Foundation. Our goal is to make a prediction using unsupervised machine learning algorithms using the iris data set. We'll be finding the optimal number of clusters in our data set. Moving towards the solution. So I've provided the link of the data set which I have used. First step is to import the important libraries which we will require in our model building and visualization purpose, such as NumPy, Pandas, and Matplotlib and Seaborn. Next is to import the data set. We have our data in a CSV format, so we'll be reading it using the read underscore CSV function. Using the head function, we can check the first 5 rows of our data set. Now moving towards the data analysis part, using the info function to check the shape of the data. So as we can see, we have 150 rows in our data set and 6 columns. So for each 6 column, I wanted to check if there are null values or not. And the data type of each of the columns. We can also use data set iris underscore df dot shape to get the shape of the data. We can use iris underscore df dot d types to check the columns and the d types of the data set, but here I used info function. Then I check the 5-point summary of our data set, if what's the mean of the different sepal length, sepal width, petal length, petal width, a minimum and the maximum values. Now we are checking the unique species in our data set, like how many species do we have in our data set. So we found that we have 3 different species in our data sets. As a part of univariate analysis, I wanted to check if there are any potential outliers or not. I have dropped the ID column and then plotted the box plot for it. Because if we added the ID column, we would have gotten higher range, higher scaled data, and it was not adding much value to our model, so I dropped it as a reprocessing step. As we can see, there are no potential outliers. Then we are moving towards the bivariate analysis. I wanted to check how what's the impact of the species on the different columns, such as sepal length, sepal width, petal length, and petal width. Now moving towards the model building. So we are using the k-means algorithm for our unsupervised machine learning. So we have given a range of 1 to 11. So for 1 to 11, our clusters will be plotted in each iteration. So we will be able to check if there are one cluster which is able to define our data set, or 2 are able to define our data set very efficiently, or 3 of the data set, 3 of the centroids are able to define our data set, and so on till within this range. And we calculated the within cluster inertia. We will be plotting this inertia with respect to the number of clusters, and an Algo would be formed, using which we can conclude that how many optimal number of clusters we need. So we can understand that 3 would be the number of clusters which we can define our data set efficiently. because after 3 it is it's not showing much of a difference. So we'll be doing the final model building based on the number of cluster 3 as we concluded from the Algo plot, and we have predicted the different categories. We'll be visualizing the clusters formed. So I've plotted a graph for each of the clusters and their centroids. The centroids are plotted with yellow for each of the 3 clusters. And so that's